In this video we're taking a look at a real-world problem involving trigonometry, and typically the real-world problems tend to be a little bit more layered. They're not more difficult, it's still the same rules, it's still the same formula, but the question is buried under some extra information that we normally don't have to deal with. So let's take a look at what extra information they have, and let's see, can we pull out the basic maths question that's hidden underneath. So it says the diagram below shows two vertical buildings, A and B. The diagram is not to scale. So there's our building A and there's our building B. It then says that Mary stands at the top of building A. She is 220 meters above the ground. Now they've marked that in the diagram for us. It then says that she wants to work out the distance marked Y and Z in the diagram. So she wants to find out this side length, and she also wants to find out Z, which is the height of building B. So that's just describing what we've talked about there. It then said Mary measures the two angles that are marked 35 and 20. So she measures this angle down here, which would be called our angle of depression if it was from the horizontal. Now it's a little bit less than the angle of depression. So it's the angle that she's recorded when she's looking down. And the other one is the angle of 20. So she's looking at the angle of elevation. Now that is the angle of elevation because it's looking at the horizontal and it's looking from her upwards. So those are our angles, and it then says that she wants to find Y and Z. But the first part of the question is for us to work out the angle C. So take a look at what is going on in the area of where the angle C is. So this is the side length that we're missing, so I can't use that side length, that's no good to me. I do have this side length down here down the bottom, which is 154, and I do actually know that this side length up here is also 220. Now you might be thinking, right, okay, it's a missing angle and I have two of the sides, so I can use SOHCAHTOA. Take another look at the question. You've got 90 degrees, you've got 35, and you've got C. What do we know about the angles in a triangle? Because that's what I've just ended up drawing out here. Well, we know that all of the angles in a triangle add up to 180. So I actually know that 35 plus 90 plus C is equal to 180. So couldn't I find C this way? So I'm now going to say that 35 plus 90, well, that gives me 125. Plus C is equal to 180. How do I get C on its own? I'm going to have 180 take away my 125, and I'm going to get C is equal to 55 degrees. Look at how much nicer, neater and more straightforward that was. Rather than pulling out a sine or a cos or our tan. Much nicer, no decimals, no rounding, straightforward, 55 degrees. The next one then, Mary works out that the horizontal distance between the two buildings is 154, correct to the nearest metre as shown. So that's it in the diagram we had up there. I'm actually going to take that triangle, I'm going to copy it and bring it down here because we can work with it here. In the exam, what I would be doing is just drawing it out. Right? I cheated a little bit here by copying and pasting, but for you, I would still encourage you to draw it out in the exam. And for me, personally, I find the colours are really helpful because now I know what they matched up with in the diagram if I need to go back up and check. So the green side, that was 220. The length along the bottom was 154. So all I've done is drawn out the triangle as required for the question. It now says using the theorem of Pythagoras. So a lot of people jump into this and they start using their sine and cosine rules because they know that this one here is 55 and they know this one up here is 35. So they start using SOHCAHTOA, start making it a little bit more complicated than it needs to be because the question asked us to use the theorem of Pythagoras. So watch out for that. If they ask you to do it in a specific way, then they want you to show off your skills for that question. So I want to find this side here, which she has started to call Y. So I'm going to call it Y. And I'm now going to use Pythagoras' theorem. So I'm going to start out by writing Pythagoras' theorem, which is a squared plus b squared is equal to c squared. Now if you've done your work with Pythagoras and you've studied it, you know that the side that matters the most, the one that you have to get the label right for, is the hypotenuse. And the hypotenuse is identifiable because it's always opposite to the right angle. So opposite to the right angle for us is y. Now which letter does that get according to the formula? It gets C. So that has to be C. The sides A and B, they don't really matter which one you call A and which one you call B. The most important one is that you get your C right. So C has to be the blue side. Alright, let's make that blue. So C has to be blue. B and A don't matter. Doesn't matter which side you call which for A and B, because the key is that you get your C right. So now I just have to make sure that I'm filling it in correctly. So I've got 154 squared. Plus, for B, the side B here is 220 squared is equal to C squared, which is actually the letter Y, and we're going to square it. So I'm going to put all that into my calculator. 154 squared plus 220 squared. If I add those two together and put basically all of that into my calculator in one go, I get 72116, and that's equal to Y squared. Now, if I want to get y on its own, how do I get rid of the square? Well, the opposite of squaring something is square rooting. So what I'm going to do is I'm going to square root this side and this side, because the rule with equations is whatever you do to one side, you must do that to the other. So I'm going to square root both sides. On the side here, it leaves me with y, and then it leaves me with an answer of 268.544. Now look at the question. Give your answer correct to the nearest meter. So if I have 268.54, then to the nearest meter, y is going to be equal to 269 meters. So be careful with that one. Make sure you've read all parts of it. Make sure you've read that they asked for Pythagoras' theorem. You had to use that, and then take a look that you've recorded your answer in the way that they wanted it, which was correct to the nearest meter. The last part then is use trigonometry to work out the value of z, the height of building B. Well, if I look at where that is involved, and we start to fill in what we can then, that 154 we said, that's the distance between the two buildings. But that's the same whether I'm at the base of the two buildings or I'm at the top of building A and halfway up building B or 3/4 of the way up. That distance is the same no matter what. So long as I'm talking about directly across, that distance is always going to be the same. So that yellow side remains the same. What I also know is I know this side length here. This green side is 220. How do I know that's the same? Well, up to here was 220. Then I go directly across. I've not gone any higher, any lower. I went directly across. That's also 220. So I know that building B at a minimum is going to be 220 plus something else. I don't know. I'm going to call this, we've used the letter Y. Let me call this X. So I haven't used that yet. I'm going to call that X. So I'm going to say 220 plus X is the total for building B. The full thing. So Z is 220 because it's taller than building A. It's at least 220 plus some other amount. I'm going to call it X. Now how do I find X? That's the question. So I'm going to give this a new colour. So I haven't used purple yet. So let's look at that. It's part of a triangle again. And in the triangle this time, I don't know as many sides as I did before. I actually only know one of the sides. And that'll become clear if you draw it out again. So I'm going to take this, I'm going to bring it down, and I'm going to redraw out the triangle. So just the triangle parts that I was interested in. I don't need that, don't need that, I don't need that. I just wanted this triangle. Now, of that triangle, what can I say? Well, if you look back at the diagram, we know that this was 20 inside here, and we know that along the bottom I'd got 154, and we've got this side X, which I don't know what the value of is it yet. But I've got two options here. It's either going to be Pythagoras or it's going to be SOHCAHTOA. If I had another side length, I could use Pythagoras, but I don't. I've got an angle, so now I'm going to be looking at SOHCAHTOA. For SOHCAHTOA, I like to write out, so katoa first. And now I need to figure out, is it opposite and hypotenuse, adjacent hypotenuse, opposite adjacent? What is it? So I have this side down here, which is 154. So ideally I'm going to want to use that in my question. 154 is the side that is next to the angle. If it is next to the angle and it is not the hypotenuse, because technically isn't this side, the pink side, isn't he also opposite to or next to the right angle? He's next to the right angle, or the angle as well. So how do we distinguish between the hypotenuse and the adjacent? Well, the hypotenuse is always opposite to the right angle. So opposite to the right angle is the hypotenuse. Next to the angle, next to it, is our adjacent side. So this 154 actually gets the label adjacent. What does our side X get then? Well, if we look at the side X, that is directly across from the angle we're going to use. So he is the opposite. So then I need to look at my trig ratios, and I'm going to look at, what do I have? I've got opposite, so it could be sine. I've got adjacent, okay, it could be cos. But what does that mean here? Well, if this one involves the adjacent, and I have it, but it also involves opposite, and I don't have opposite in cos. It can't be cos, can it? If I look at this sine, the other side that I have is adjacent. Does sine involve the adjacent? It does not. But if we look at tan, tan is opposite, I have. Adjacent, I have. It's going to be tan. So now I write that out. I'm going to have tan of the angle is equal to opposite over adjacent. Now, the opposite side to my angle, if I get that right, the opposite side is directly across from it. It's the purple side. What is the adjacent to my angle? The adjacent is the 154 down here. So now I just fill it in. It's not a mystery angle. I actually do know what the angle is. So it's going to be tan of 20. So I fill in what the angle is equal to opposite, which is x. I don't know what that is. All over adjacent, which is 154. I now want to get x on its own. So I'm going to have to think about what is that 154 doing to that x. And if you look at it, it's dividing. How do I undo that? How do I undo divide by 154? Well, the trick is to multiply both sides by 154. So that leaves me with x is equal to 154 multiplied by tan of 20. So I just popped that into my calculator. So 154 multiplied by tan of 20, and I'm getting that it's 56.05 meters. That's what x is for now. But remember, was that the question? Am I finished? It says use trigonometry to work out the value of z, the height of the building B. If I go back up, does it make sense for the height of the building to be 56 meters? Let's take a look. So 56 meters. Now it can't be 56 meters because it's taller than building A, which is 220 meters. So I know it has to be bigger. But remember what we said at the beginning. This is kind of our clue now. We said that the height of the building is going to be 220 plus x. And now I know what x is. It's 56. So I'm now going to go back down. I'm going to say that we're nearly there. We're going to say that z is equal to 220 plus 56. 0.05, you can put in the 0.05, but we're going to round it in a second. So it's going to be 276.05, but because they said correct to the nearest meter, we're going to say 276 meters. And that's it. So the big tip I have for tackling these kind of real world problems is to dissect it into the right angle triangles that you're used to seeing in the questions. None of it was particularly hard, but it was just buried underneath lots and lots of other information. So pull out your triangles. The best way to do that is to use colours.